Hello and welcome. In this video, we will explore few more examples for converting context-free grammar to Chomsky normal form. This is in continuation with the first video. In first video, we have already discussed few examples. So if you have any problem, you can refer the previous video. This is the context-free grammar that we need to convert it into CNF form. As a first step, we need to simplify the grammar, and simplification we can do by following three rules. Again, I insist you to watch 3 videos on the simplification I have already uploaded. The first step is to remove the null productions. So we have 2 null productions. A implies epsilon, D implies epsilon. So to remove the null productions, wherever A and D appears, we have to replace it by epsilon. So in the first production, S gives double ACD. If we replaced first A by epsilon, then we will get ACD. If we replace both A by epsilon, we will get only CD. If we replace D by epsilon, we will get double AC. And if we replace both the A and D with the epsilon, then we will get only C. In second production, A gives AAB, that will remain as it is. And then we have to replace that capital A by epsilon because A derives epsilon. So we will be left with only AB. In production of C, there is no nullable variable, so that will remain as it is. In production D, D is nullable variable. So we have to copy all non-epsilon production as it is. That is D implies ADA and D implies BDB. And then we have to replace D by epsilon. So we will be left with double A and double V. So this is the grammar without null production. As a second step, we have to remove unit production. So do we have any unit production in production of S? Yes, we have. S gives C. So that C we have to replace with the productions of capital C. So capital C derives AC and A. So the production S derives C will be replaced by AC and A as shown in red color. In remaining all the production, there is no unit production, so we will keep all them as it is. And the third step is to remove useless symbol. But from S we can derive A, we can derive C, we can derive D as well. So there is no useless symbol. So this is the grammar which is simplified. In step 2, we have to convert every symbol in the production of the form A gives alpha, and if length of alpha is greater than or equal to 2, then we should replace all the input, all the symbols by variable or by the capital letter. So if we consider the first production, then S derives double ACD, all symbols are capital letter. S derives ACD, all are capital letter. S derives CD, all are capital. S derives double AC, again all are variable or the capital. S derives AC also fine. But S derives small a capital C. It is having length greater than or equal to 2. But both symbols are not variable. So that terminal symbol A we have to replace by some non-terminal or the capital letter. So instead of A we are assuming XA. So XA is not 2 symbol, it's just a 1 symbol. Okay, as I earlier told you that XA represents replacement of A by X. So just to understand that or to make the thing simpler, we are writing A in a subscript. So XA is a 1 symbol which is replaced for small a and then capital C. Then we have a S derives A, small a. But this production doesn't have length greater than or equal to 2. So we don't have to replace that A by XA. Remember that. Only in the production where alpha is greater than or equal to 2, we have to replace them by non-terminal symbols. If it is less than 2, we don't have to touch them. In production, A derives small a, capital A, small b. There are 3 symbols and there are 2 terminal symbols. So both the terminal symbols we have to replace by non-terminal or the variable. So small a we are replacing by capital XA and small b we are replacing by capital XB. Similarly, C derives AC here. The first production of C is of length greater than or equal to 2 and hence that A we are replacing by XA. But in second production of C, that is C derives A, the right hand side of the production is having length 1 only. So we don't have to replace that A by XA. Understand that. And similarly in production of D we will replace all small variables by the capital variables. So this is the set of productions after step 2. And we have added introduced two more productions. We have assumed XA for small a and XB for small b. So this is the complete set of production that we have derived using step 2. Now we will convert all the productions in CNF form. So productions in CNF form could be of two forms. One is on right hand side of any production there should be exactly two non-terminal, or there should be exactly one terminal symbol. So if we start with the first production of S, which is S derives double ACD, there are four symbols. We need only two. So first we'll copy S derives A, and for remaining part ACD, we will assume one variable V1. Okay. So first production will be of the form S gives A V1. Now V1 is ACD, V1 derives ACD, but as there are three symbols, we will copy A as it is, and for CD we will assume some another variable V2, and that V2 will derive CD. So now this is in appropriate form. For the second production of S, S derives ACD. So again, it is having three symbol. So we will write it as a V2 because V2 derives CD. So that CD part of second production we can replace by V2 variable. Third production of S derives CD is already in CNF. Fourth production S derives AAC. So this is not in CNF because there are three variable. So to make it 2, we will assume some variable V3 for the AC part. So now that will become AV3 and V3 will derive AC. So it is in OK, in a proper form. Then next production is S derives AC, it is in correct form. S derives XAC, it is also in correct form, and S derives A is also in correct form. So production of S are now in CNF form. The production of A derives XA, capital A, XB. It is having three symbols, so it is not in CNF. So for A, XB, we will assume some variable X4, V4, and V4 will derive AXB. So now all the productions of A are in CNF form. Productions of C are already in CNF form because they are either two non-terminal or one terminal. These first two productions of D are not in CNF form. So we will assume some variable V5 for DXA and V6 for DXB, and we will have V5 derives DXA, V6 derives DXB. And remaining two productions, last two productions, XA derives A and XB derives B, are already in CNF form. So this is the Chomsky normal form of given context-free grammar. Consider the another example, S derives SS oblique epsilon. Now to convert it into CNF, we need to convert it into simplified grammar. So as there is an epsilon present, we have to remove the null production or the epsilon production. So when we remove the epsilon, we will replace that capital S by epsilon. So when we remove the first S, it will become just a parenthesis, S parenthesis. If I remove the S within the parenthesis, then we will have grammar S opening parenthesis, closing parenthesis. And if we eliminate both the capital S, or we replace both S by epsilon, then we are left with just a parenthesis, opening and closing. So this is the grammar without null production. Now this grammar is already simplified because there is no unit production, there is no unreachable symbol. So so this is correct grammar. Now on this we will apply step 2 of CNF conversion. So if any production is having length greater than or equal to 2, then we have to convert it into variable. For first production S derives S, then opening parenthesis is terminal, then capital S, then closing parenthesis is terminal. So there are four symbols in the first production of S. So for opening parenthesis and closing parenthesis, we will assume the variable capital O, capital C. So they are the variables for representing opening parenthesis, closing parenthesis. So first production of S would become S, capital O, capital S, capital C. Second production of S is S derives S within parenthesis. So parenthesis will be replaced by capital O, then capital S, then capital C. Then third production of S is S derives capital S, then parenthesis. So it will become S, capital O, capital C. And last production of S is S derives opening and closing parenthesis, which will be ultimately capital O, capital C. And we have assumed that capital O derives terminal symbol opening parenthesis and capital C derives closing parenthesis. Next, we have to make sure that all production should be in CNF form. So right hand side of production should have exactly two non-terminal or one terminal. First production of S is violating the rule So we will assume variable v1 for OSC in the first production of S. So we will have S derives SV1 and that v1 will derive OSC, but as there are three symbols, so we will have to take some another variable for that. So let us consider it as a v2 and v2 will derive ultimately SC. The second production of S is S derives OSC. So we already know that SC is derived by V2. So we can directly write it as a OV2. Third production of S is S derives SOC. It is having three symbols. So OC we have to replace by some variable. Consider it as a V3. So we have to add one more variable. V3 derives OC. So all productions of S are in CNF form. The remaining two productions are already in CNF because that variable derives exactly one terminal symbol. So this grammar is in CNF form. Thank you. That's it for today, folks. See you in next video. If you think this video was useful to you, then please like, comment and share. Don't forget to subscribe the channel CodeCrucks. Press the bell icon for the notification of latest videos. Stay connected, stay tuned. Thanks for watching. Bye-bye.